Hello all, welcome back to yet another video of this today's lead code daily challenge, and let's solve the problem. The today's problem is nothing but minimum number of arrows to burst balloons. What is the problem stating about? There are some spherical balloons taped onto a flat wall that represents the xy plane. The balloons are consider this as xy plane, and the balloons are represented as 2D integer array points, where points of I is nothing but the x start and x end denotes a balloon whose horizontal diameter stretches between the x start and x end. You do not know the exact y coordinates of the balloons. We do not know the y coordinate, that is the height of that balloon. We know the width, that is the horizontal diameter. Arrows can be shot up directly vertical in the positive y direction from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot at x if x is greater than or equal to x start and lesser than or equal to x end. So there is no limit to the number of arrows that can be shot. A short arrow keeps traveling up infinitely, bursting any balloons on its path. So given the array points, return the minimum number of arrows that must be shot to burst all balloons. So we want to find how many number of arrows that should be shot to burst all the balloons. So consider this is the points for every balloons, and this is the nothing but the horizontal diameter. If we consider these are the points of four balloons, let us paste here. So first balloon ranging from 10 to 16. So let us keep like this. Let us draw a line from 10 to 16 as one balloon. This is the first balloon. 10 to 16. This is the first balloon. Consider this is the first balloon. The second balloon ranging from 2 to 8. The second balloon ranging from 2 to 8. And the third balloon ranging from 1 to 6. The third balloon is ranging from 1 to 6. 1 to 6 in the sense it is somewhere here. 1 to 6. It will be like this. And the fourth balloon, which is nothing but 7 to 12. The fourth balloon is from 7 to 12. 7 will be somewhere here. 7 to 12. Yeah. So this is nothing but 7 and this is 12. And this first balloon is from 10 and the end is 16. And this second balloon is from 2 to 8. 2 to 8. And this third balloon is from ranging from 1 to 6. So how many if we are what the problem states is nothing but we are going to have an arrow that is going in y direction. This arrow is going in y direction, and if we point one arrow, then that is going to go till infinitely. Then if we shot an arrow from somewhere here, then this arrow will obviously burst this balloon 2 to 8 and the balloon which is having a range from 1 to 6 diameter. So this one arrow will be able to burst these two balloons. These two balloons will be bursted out. And if we have an arrow somewhere like this, somewhere here, then this balloon alone gets bursted out. And if we have an arrow like the arrow like here, then that would burst this balloon. So here we require here we require three arrows to burst all the balloons, but we want to find the best case, that is the minimum number of arrows to burst all the balloons. So let us try in some other possible answer. What if we burst what if we have an arrow like this? If we have an arrow like this, then this arrow will burst this balloon and this balloon. But if we have an arrow at point, if we have an arrow here, that this will burst this balloon and this balloon, but this balloon, to burst this balloon we need another arrow, and to burst this balloon we need another arrow. That ends up having three arrows to burst all the balloons. But what if we have an arrow here? This arrow will burst these two balloons. And what if we have an arrow here? This arrow will burst this balloon and this balloon, and ending up we have two arrows. We just require two arrows to burst all the balloons. So this is what the problem states. I hope I'm able to give a visualization for this problem. Hope you understand what the problem states. But how can we solve this problem? So how to minimize the number of arrows, we need to know what are the merging intervals, right? This balloon is this balloon and this balloon are merged, so we can just have one arrow to burst these two balloons instead of bursting the other, right? That is what my observation, first observation is. Now let us take the second example and similarly do the same stuff and see. um, just a minute. Where is the eraser? Yeah. So in second example, how we can draw the balloons? Mm, the first balloon is ranging from 1 to 2. Let us say it is from 1 to 2. And the second balloon is from 3 to 4. The second balloon is from 3 to 4. Let us say 3 is from here, 3 to 4. And the third balloon is from 5 to 6. 5 is here, 5 to 6. And the fourth balloon is from 7 to 8. Let us say 7 is here, 7 to 8. So as you can see, if I have one arrow here, only one balloon can burst out, and I should have another arrow here, I should have another arrow here, I should have another arrow here. So we need total 4 arrows to break it, to burst all the balloons. So now let us see the third example as well. So what will be the maximum number of arrows that are needed is nothing but the total. We can see n arrows are needed to burst all the balloons if we have one arrow for each balloon. But we are required to find the minimum number of arrows. So in the example 3, the balloons are 1 to 2. So let us have 1 to 2 here. And 2 to 3, we are having a balloon from 2 to 3. And 5 to 6, a balloon from 5 to 6. And sorry, not from 5 to 6, 1 to 2, 2 to 3, 1 to 2, 2 to 3. Then actually, so the third balloon in our case is nothing but 3, 4. So just a minute, 1 to 2, 2 to 3, then balloon from 3 to 4, and balloon from 4 to 5. So to burst these balloons, where shall keep where we can keep our arrow? If we keep our arrow here, then it will burst only one balloon. Instead, what we can do is we can keep an arrow at the point 2 itself. So what does is this will burst these two balloons. So if we have an arrow at this particular point 4, then this will this will burst these two balloons. So we can have only two arrows to burst both the all the four balloons. So that is what required. So how can we solve this problem now? First, what we can do is we can first try to sort the given points. Then we can get some idea. So 1 to 6 is 1 to 6, then 2 to 8, then the balloon is nothing but 7 to 12, and the next balloon will be 10 to 16. So this will be the sorted order of points. What we can do is we see some overlapping between these two intervals. So if 2 and 8 is going to be overlapping with 1 and 6, then we know that these two balloons are overlapping with each other, and we can have only one arrow to burst both of them. So then 7 to 12, if it is overlapping with this 6, then we can say still we can have only one arrow to burst all the three balloons starting from 1 to 6 till 7 to 12. But as you can see, 1 to 6 and 7 to 12, it is not overlapping, right? 1 to 6, and then only the balloon 7 starts, and we need an extra arrow to burst this balloon 7 to 12. So now our end time will become 12, and we want to check whether we can have some balloons which is overlapping with this 12. If some balloons which is overlapping with this 12, then we do not want to increment our arrows, and still that arrow itself can burst all the balloons starting from this range 7 till the overlapping part. But if there is some balloon which is starting range is more than 12, that is nothing but 13 or 14 or so on, then we know that there should be an extra arrow to break that balloon as well. So what I say is we can start from this first index, first balloon, and that first balloon the first balloon is nothing but, once we have sorted all the points, the first balloon's end point we can note, and we can keep track, and we can say our number of arrows that is needed to burst the balloon is 1, and we can iterate over the points array. And if we see some overlapping part with this end, where if we check the starting x coordinate with this ending point, if it is going to overlap, then we can say that previous arrow itself is enough to break this balloon as well. But when it breaks the condition, when the overlap is not there, that is 6 and 7 is not overlapping between them, so I need an extra arrow to break this balloon 7 to 12. So now my ending part is nothing but this 12. So and again I want to check whether I have any overlap or not. This will be holds true when this will be holds true for all the cases as we sort the points array initially itself. Now how can we solve this problem is, first we can sort the array. So the time complexity for the solution overall will be n log n, because we are sorting here. So once we sort this array, what we can say is we can have a count arrows which is initially going to be 1, and finally at the end of the day I'm going to return this arrows only. This is going to keep track of the minimum number of arrows that is needed to burst all the balloons. So arrows number is 1, and our initial end point in the sense, till this point I have this one arrow, I have the number of arrows to burst all the balloons. So that is what I am going to denote with this end variable. So end is nothing but this points of 0 1. So this is going to be my end. So I'm going to start from this first index for int I equals to 1, I less than or I less than n, I plus plus. What I'm going to do is, first I will take the start. Start is nothing but the points of I 0, and what is my end? End is nothing but, end is not it is not end, let us say x start and x end. That is what they denoted. It is known as x start and x end, right? Okay, x end is nothing but the points of I1. So why we need x end, I will tell in few minutes. So now we want to check for two cases. If my x start x start is lesser than or equal to the end, then I don't want to have an extra arrow. The previous arrow itself will burst all the balloons. Then this is an overlap. But if this is not an overlap, then what we can do is we can increment our arrows variable, and we want to update our end. My end is nothing but this x end. So hope you understand. Now let us try to run our code. That's it. It is as simple as that. Sorry, n I have not declared. Int n is nothing but this points dot size. Yeah, now let's run our code. Great, it gets accepted for all the 3 test cases, and I believe it will get passed for all the test cases as well. Okay, it gets a wrong answer. We get some wrong answer. Let us see. I have actually tried out a cout statement on the points for the failing test case, and after analysis, I found that it is due to this end end coordinate, because you can see the end coordinate is not at all in sorted order, and this is going to cause an issue where the 6 to 7 balloon is in between 2 ranges, but our logic is actually counting only 1 arrow, but which is expected to be 2 arrow. That minimum number of arrows that is required for this test case is actually 2. So what we can do is we can sort based on the end points instead of having the sort points, but the core logic remains the same. So what we can do is we can actually have a custom comparator here. The custom comparator is going to sort based on the end points of the point. Sorry. So let us have static bool custom comparator vector int ampersand a and vector int ampersand b. This is going to return me based on the second coordinate, which is nothing but a1 lesser than b1. So this will sort the based on the second coordinate, so that our logic still stays the same. And let us try to run our code. Yeah, it gets accepted, because once the endpoints are sorted order, we definitely will count the arrows once they do not overlap. So that is what happens here. So now let us submit our code. Great, it gets accepted. So hope you like the solution, and let me know in the comments, and hope I made you and visualize what is the problem and how to solve. And so let us see in tomorrow's LeetCode daily challenge. Until then, bye.